Okay, so we are back at it for our last lesson on exponential functions, and today we're going to talk about exponential decay. Just as a reminder, if you want to follow along, you can feel free to print out the written notes off of the Schoology site. Over here, we have our calculator that we're ready to use. It's already been reset. And today we're talking about exponential decay, and our objective is to be able to solve problems involving exponential decay and half-life. So we're going to go ahead and get started with that. The first thing, just like when we did exponential growth, is that we have this equation for exponential decay, which is y equals a times 1 minus r to the power of t. So it's the exact same equation as exponential growth, except there's a minus sign. So we're decaying that amount. And our definition of exponential decay is it's an initial amount that decreases at a steady rate over time. So it's our initial amount, which is still a, that decreases at a steady rate r, which again we're turning our percents into decimals, over t time, which most of when we see these problems is in years, and y is our final amount no matter what. So it's the same exact equation, except this time it's minus because we know decay. And we know that when our b value was greater than 1, it was growth, and when it's less than 1, it was decay. So this is where we get that less than 1 because we're subtracting that rate from 1. So our first problem says that a new car in 2005 cost $20,000. The value decreases 60% each year, and we want to find the value in 2011. So the first thing I see is this word decrease. That's how I know I'm going to use exponential decay. And I know this because words like decrease, loses, depreciation, those all mean exponential decay. So I'm going to write the equation I'm going to use, which is y equals a times 1 minus r to the power of t. Y equals a times 1 minus r to the power of t, and we got that from this decreases thing over here. And just like yesterday, we need to figure out what y, a, it's really long a, r, and t. So we have y equals, we have a equals, geez, it's a hot mess. Let's erase that, make that look a little better. A equals, r equals, and t equals. Okay? So we need to find out what each of those things are equal to in order to plug them into the equation. Y is my final amount, which is what I'm looking for. So I don't know what that is yet. A is my starting amount, which we know that when I bought this car in 2005, it was worth $20,000. So that means my initial amount is $20,000. The rate, it's decreasing 16% every year, but we want to turn that percent into a decimal. So I'm going to make it 0.16. And the amount of time that's gone by is going to be 6 because 2011 minus 2005 gives me 6 years. So I'm going to plug all of this information into that equation. So y equals 20,000 times 1 minus 0.16 that was weird. Alright. Raised to the power of 6. Not sure why it stalled there for a second. Okay, I'm going to keep simplifying, so I'm going to have y equals 20,000 times 0.84, because 1 minus 0.16 is 0.84. If I want, I could double check that on my calculator. We're still going to raise it to the power of 6. So I go over to my calculator, I'm going to double check and do 1 minus, whoa, that was weird. Okay, 1 minus 0.16, we get an answer of 0.84, which is what we had. We're going to raise that to the 6th power. We get 0.35129803116, which is a really kind of ugly number. We're going to multiply that by 20,000. I hit enter. And again, this is money, so I have to make sure I'm watching how I'm rounding. And that car in 2011 is going to be worth $7,025 and 96 cents. Again, you just have to watch out for the rounding, just like we were the day before. Let's fix the 0. We'll add a comma. So this is my answer. Alright, so I'm going to have you guys try to start this one. The first part we need to do is we need to write an equation, and then we're going to solve it for 7 days. So the equation, you're just going to leave t by itself, and it says a fully inflated raft loses 6.6% of its air every day. The raft originally contains 4,500 cubic inches of air. So let's start. I'll give you about 5 seconds to write down a formula. So pause the video now, so that way you can try it by yourself, and we'll do the second part of this question next. Okay, so here is that missing information that we were trying to find. We know that this is going to be exponential decay because it talks about how the raft is losing 6.6% of air every single day. So our initial amount is this 4,500, our rate is 0.066, and we don't know the time. So we have to write an equation, and we're going to want to, simplify that. So I know it's going to be y equals a times 1 minus r, because again it's decay, to the power of t. I'm just going to plug in the information that I had over here. I'm going to write it down here so I have some more room. Y equals 4,500, so that was my starting amount of air, times 1 minus 0.066 raised to the power of t. I can keep simplifying this actually a little bit further. All I have to do is do 1 minus, okay, I keep pressing the wrong button, 1 minus, let's go, 6. I'm going to replace that right there, so I'm going to have 1 minus 4,500 times 0.934 that raised to the power of t. So this is the simplest form of that equation. I'm going to give you a couple minutes to figure out how you would plug in this information for our equation. Okay, so we plugged in 7 for where t was, because at the beginning of the problem it said that the time going by was mentioned in days, so we didn't have to assume that it was years, and we didn't have to solve anything from there. I just plugged in 7 where t was, so 0.934 raised to the power of 7 was 0.62005 20299. We multiply that by 4,500, and we got 2,790.234 cubic inches of air. So this is not money, so you don't have to round to the nearest hundredth or the nearest penny. You just have to kind of figure out what is the best way to round to and make sure that your rounding is correct. All right. So in the next problem, it says the following equation models the evaporation of Lake Dart, and what is the decay rate? And I know this is decay because it says decay rate for 1. The other part is it says evaporation, and this value right here is less than 1. When the b value is less than 1, it's decay. So I know that the decay equation was y equals a times 1 minus r to the power of t. So when I go to solve this, y is still the same, 50,000 is a. I'm not looking for those. What I'm looking for is this rate right here. And in order to find that, I have to say that these two things are equal. So this right here is equal to this right here. And I'm going to solve exactly that. So I'm going to say 1 minus r is equal to 0.9. I'm just going to use algebra to help me solve that. So I'm going to subtract 1 from each side. And I'm left with negative r equals negative 0.1. You can either divide or multiply both sides by negative 1 to continue to get r by itself. Oops. not negative r, negative 1. It turns this into a positive. So that means r is equal to 0.1, which rate is always listed as a decimal, but we want to change this to a percent because it's a rate of decay. So we're going to make this move the opposite way as we did the day before. This is 10% decay. There's easier ways to do this. This is just the easiest way to start off kind of explaining how that works. So it is a 10% decay at Lake Dart. Okay, and the last type of problem we're going to talk about, and this is our last equation, is half-life. And half-life is the time it takes for a substance to decrease in half. So A is our final amount, just like it was for compound interest. P is our initial principal, again, just like it was before. Our rate is 1/2, and it's always going to be that. And T is something different this time. T is the number of half-lives taken. So it's not time, it's the number of half-lives that we take during that problem. So for this question, it says fluorine 20 has a half-life of 11 seconds. Find the amount of fluorine 20 left from a 40-gram sample after 44 seconds. So I know it's a half-life problem because it actually says half-life. So I'm going to use A equals P times 1/2 to the power of X or T or whatever you want to figure out. I'll make it T just because that was what our original equation was. So I'll erase this, come back to T. Okay, so I need to figure out what A is, if it tells me. I need to figure out what P is and what T is. So I don't know what my final amount is left. I know that I'm starting with a 40-gram sample. And T is not time. T is the number of half-lives taken. So 44 seconds are going by, but it takes 11 seconds for it to cut in half. So what I'm going to do to figure out how many half-lives I take, I'm going to take 44 and divide it by 11, which gives me 4. So that's my T value. So that means I'm going to have A equals 40 times 1/2 to the power of 4. I'm going to go through and solve that. So I have 1/2 to the power of 4 times 40. And I get 2.5. So that means there are 2.5 grams. So after 45 seconds, we are only left with 2.5 grams. And that is how we do half-life. There's more examples on the notes in case you're looking, and there's a way to actually solve it using a table in case they do give you the final amount and you have to find the number that's there. If you have any questions on the extra work, please feel free to email me. Otherwise, good luck, and don't forget to do your discussion board posts. Thanks. Bye.